Could seagrass be the antidote for our climate crisis? Seagrass is one of the world's most threatened species in coastal ecosystems, and yet it might be the world's savior. An ancient organism that protects our coasts, seaweed also provides shelter and food to thousands of marine creatures, and is widely used in foods, cosmetics, and medicines. Driving their nutrition through the process of photosynthesis, these tiny creatures produce 10 liters of oxygen per square meter every day. No wonder they are known as the lungs of the sea. And other studies reveal that these marine plants have been playing an active role in climate conservation. Well, we all know that carbon dioxide CO2 molecules absorb the heat energy in the atmosphere. This means that the more CO2 molecules there are in the atmosphere, the hotter the temperature gets on Earth, leading to global warming. This is where seagrass plays its part. It tackles climate change by acting as a natural CO2 sink and absorbs up to 10% of ocean's carbon annually, roughly 35 times faster than what tropical rainforests would absorb. But seagrass meadows occupy only 0.2% of the seafloor, and over the last century, they have drastically diminished worldwide.
The impact of the 1 billion or more people who live within 50 kilometers of them is largely the cause, including damage from coastal development and degraded water quality from nutrient pollution.
In 2022, more than 100 countries joined hands at COP27, where they discussed the critical issues facing fisheries and agriculture. Many research groups around the world are also trying to find ways to preserve, restore, and develop methods to replant seagrass in barren areas. Europe has lost one-third of its sea meadows, and this project by Geomar aims to regreen the Baltic Sea by developing hands-on training on seagrass farming. Scientists are also researching how resistant seagrass is to rising temperatures, hoping to breed more heat-resistant strains as the ocean warms. Well, there's a catch. Determining whether CO2 can be captured and stored at the bottom of the seabed is complex. This research requires a detailed study of species and ecosystems, along with interactions between various organisms within and around these communities, as well as prevailing environmental conditions. Certain scenarios reveal that seagrass in some ecosystems may produce more carbon than they can capture. While it looks like a work in progress, will researchers be able to overcome these limitations and help mitigate the climate crisis?